Okay, you guys, so today we're going to finish 10B. We're getting kind of close to the end of the course. We may not do another section, but for 10B, problem solving with geometry, we're going to kind of skip around. The book has a whole bunch of like scattered information in this section, so I'm going to kind of pick the kind of my favorite parts of 10B. So measuring angles. So obviously, many of you have, dealt with angles in the past. And a lot of times we like to think of angles like this. Oh, that's pretty bad. Hold on. Okay, so let me do it like this. In trigonometry, we oftentimes talk about the unit circle. But what we can do is we can always say in general, when we're measuring an angle, it starts right here. Okay, and this is 0 degrees. And then if we rotate all the way around and do one full rotation, that is 360 degrees. So it ends in the same 0 degrees and 360 degrees ends in the same location, but 360 degrees tells you that you go all the way around. Okay. Now, if you don't want to think of it in terms of a circle, you could just start here with a point, right? And then you look at this and then you just rotate it and guess what you get? You get a circle if you go 360. So, basically what we're going to do is the book kind of made this pretty fancy. I'm just going to try to explain it in a nicer fashion. It says to measure angles more precisely, each degree is subdivided into 60 minutes of arc, and each minute is subdivided into 60 seconds of arc. So we call this little distance here, right there, that little distance I'm talking about, that's like our arc. So when you're doing trig and stuff, you worry about radian measure, and that's a relationship of the arc length to the angle that would be created. And since we're working with degrees, they're still going to call it that arc, but they don't mean like an actual length. They're just saying that this is the degree measure right here is 1 degree. Okay. So for me, the main thing I want to take you to take away from this is 1 degree is 60 minutes and 1 minute is 60 seconds. Okay. So that's how we get much more precise measurements. Sometimes we'll do them with, you can use them with longitude and latitude. And, I think I've worked on a few problems that are having to do with ships, and ships use a lot of minutes and seconds. But in general, they don't come up often in our daily lives, but I'm going to teach you how to do it if asked. So for this first one, for part A, it says convert 3.6 degrees. We want to end up with degree, minute, seconds. Okay. And sometimes there are no seconds, or I should have abbreviated that one too. So what I'm going to do is I'm going to say, well, 3.6 degrees is really 3 plus 0.6 degrees. So all you really worry about is this part right here. You really only care about the decimal because remember, you use minutes and seconds for more precise measurements. So the 3 degrees is going to kind of stay, right? So we're not going to worry about the 3. The 3 degrees is going to stay. We're more worried about the 0.6 degrees. And this is also degrees as well. So what we're going to do is we're going to come over here and we're going to take this 0.6 degrees and we're going to multiply it. We're going to multiply it by 60 minutes over 1 degree. Okay, or you could just think of it as multiplying it by 60. But here's the thing, is you see the degree symbol? The degree symbol is going to cancel with that. So what you're left with is simply 60 or 0.6 times 60 minutes. So this would equal 36. If you multiply this on your calculator, you get 36 minutes. Okay, so 3.6 degrees is equal to 3 degrees and 36 minutes. Now, because there wasn't an extra decimal, we don't have to worry about seconds. Okay, so let me do another one for you guys. So let's take, this is like another A sub 1. Let's do another A, or A, let's call this part A sub 1. Let's do A sub 2. So let's convert, let's go 61.24 degrees, and let's convert this to degree, minute, seconds. Okay, So this is a problem that's not listed here. I just wanted to add this one because that one was a little bit too easy. So what we're going to do is, once again, we're going to do 61 degrees plus 0.24. 0.24 degrees. Okay, so we're going to do the same thing as last time. Oh, by the way, the reason that I used this is called a unit conversion. Basically, because they told us right here that 1 degree is equal to 60 minutes, that means that if I take 60 minutes and I divide it by 1 degree, I get 1. Right? So I'm multiplying by 1. You're allowed to multiply anything by 1 and it doesn't change the value. So I chose to multiply by a fancy 1, right? It doesn't look like 1, but that's what it is. Okay, so we're going to come over here and we're going to have our 0.24 degrees. We're going to multiply this by 60 by 60 over 1 degree once again. And this is going to be, let me get out my calculator. So I'm going to do 0.24 times 60. Okay, so this would be 14.4 minutes. Okay, but here's the problem. We still have a decimal, so we want to be more accurate. So now 14.4 is really 14 minutes plus 4.4 minutes. So I'm going to convert this little decimal chunk right here to seconds. So this will become 0.4 minutes times 60 seconds over 1 minute. And once again, it's because they told me that 1 minute is worth 60 seconds. So then that means I can do 60 seconds over 1 minute. And this, by the way, this little, notation is how they do minutes and seconds, okay? And when they're talking about angular measurements. All right, so we're going to do the same thing over here. And this is going to become, let me see here, should be 24. And once again, the little labels cancel, right? Those little labels cancel. And we're left with 24 seconds. So that means my final answer is 61 degrees, 14 minutes, and 24 seconds. Okay, so this would be my final answer. So this is so 61.24 degrees is equal to 61 degrees, 14 minutes, 24 seconds. So this is another way to write this, okay? So now let me do this other one, convert 30 degrees, 33 minutes, and 31, okay? So let's do 30 degrees. Well, you know what? I'm going to do it. I'm going to do a different problem. I like mine better than that one. So I have 60, so convert to decimal degrees. So in the other example, we wanted to convert it to minutes and seconds. Now we want to take 61 degrees, 42 minutes, and 21 seconds. And we want to write this as degrees. So this is how I do it. I basically take the 61 degrees and I leave it off by itself. And then I take and I do 42 divided by 60 plus 21 divided by 3,600. Now, the reason is, since I already showed you this part right here, right? We're multiplying by 60 and then we're multiplying by 60 again. Well, that means when we come over here, when we go the other way, we have to divide by 60 for the minutes, and then we have to divide by 60 times 60, which is 3,600. Remember, 60 times 60 is 3,600. So that's where I got this guy from right here, okay? So let's just see what we get. So this will be 61. Now, this will be plus degrees plus 0.7 degrees. And then you take out your calculator and you do 21 divided by 3,600 and you get 0.00583 bar degrees. And that just means it repeats itself on and on. So I'm just going to round, let's just say we round to 1 decimal place, 1 degree. 1 decimal place degrees. So this would be 61.70583 bar degrees. So I'm going to round this off to 61.7 degrees. And that's how you can take a decimal. I'm sorry, that's how you can take minutes and seconds and turn it into decimals. All you do, you divide the minutes by 60 and you divide the seconds by 3,600. And then you add up the decimals you have left, which in this case would be this and this, and that gives us our value, okay? So I just wanted to show you guys that. So let's move on. So fractional degrees, we already did that. Angular size and distance. I'm gonna actually skip this. Not too concerned about this for our class. I wanna focus more on similar triangles and Pythagorean theorem. So the Pythagorean theorem applies only to right triangles. So remember we talked about right triangles have this little box in the bottom to tell us that it has a 90-degree angle. So it says for right triangles with side lengths A, B, and C, in which C is the longest side, we call it the hypotenuse. The Pythagorean theorem states that A squared plus B squared equals C squared. Now, it has something to do with this. A long time ago, I had to do this in my class. If you take C and you extend it, and so this is side C, this is side C, this is side C, this is what the Pythagorean theorem is saying. Take side A and make a square right here as well. So this is side A, side A. They're all the same length. And then you could take side B. It's kind of hard to do it, and make them all the same length. So that would be side B, side B, side B. If you find the area of this, that would be B squared. If you find the area of this, that would be A squared. And if you find the area of this, that would be C squared. What the Pythagorean theorem says is if you add up this area plus this area, it will equal this area. That's what the Pythagorean theorem actually says. So this isn't a proof per se. This is just kind of showing you the idea behind it and where it kind of came from. Okay. So the main reason you use the Pythagorean theorem is to find a distance usually. If it's a word problem, they normally give you 2 points and they want you to find the shortest distance between these 2 points. So you know, if I give you a point here and I give you a point here and I want to know this distance, well, I just do this, boom, boom, and I have a right triangle and I can use a Pythagorean theorem. So in general, you use the Pythagorean theorem when you're given 2 side lengths of a right triangle and you want to find the third. So when given 2 side lengths of a right triangle, you may use the Pythagorean theorem to find the third. Okay, so, and again, it has to be a right triangle, okay, and you have to be given 2 sides for our class. So what we're going to do is we're going to look over here. It says find the area in acres of the mountain lot, okay. Well, you guys know that the area formula is equal to 1/2 base times height, okay. The problem is that for and this is the area for a triangle, right? So the area of a triangle can be found by doing 1/2 base times height. So we know the base, that's right here, right, along the river, but we do not know the height. This is not the height, that is the hypotenuse. We actually need this guy right here. We need this length right there. So what we're gonna do is we're gonna say, well, I'm gonna set up A squared plus B squared equals C squared. I'm gonna call this my A, I'm gonna call this my C, so then this must be my B. And I'm just gonna plug in what I know, okay? Because once I find side B, then I can find the area. Okay, so A is 250, so I'm going to do 250 squared. B is I don't know, okay, and then C is 1200. 1200 squared. Okay, so it's calculator time. So we have 250 squared. This would be 62,500. Plus B squared equals 1200 squared. This would be 1,440,000. I think, yeah, okay. So we got that. So now our job is to solve for b squared. Well, you guys remember your old school math, right? We got to subtract to get b squared alone. Okay, so I'm going to do this minus 62,500. So I get b squared equals 1377500. So 1,377,500. And then if you want to find out what the answer is, hopefully you guys remember, you square root both sides. And this will cancel that. Whenever you want to undo a squared, you square root it. Or whenever you want to undo a square root, you square it. Okay, so now I just have to do second function square root, second function answer on my calculator. And I get an approximate value for b. B is equal to 1,173. Let me see how many decimal places your book wants. Let's go with, let's round to the nearest whole number because they're using whole numbers. So 0.669. So I'm going to use B equals 1174 feet. So this is my value for B. So I now know that this is 1174. So now I can come over here and I can find the area of my triangle. Okay, so area equals 1/2 the base. Well, the base is 250. And the height is B. So that is 1,174. So let's see what we get here. So 0.5 times 250. And again, I'm just doing all this on my calculator, you guys. So hopefully you got your calculator with you. So this is 146, 750. And this is feet squared because this is feet times feet. And whenever you're finding area, feet times feet is feet squared, yards times yards is yards squared, so on and so on. Okay. I get 146,250 or 750 feet squared. Okay. Now the problem says, let's see here. Find the area in acres. So that's the area in square feet. Okay. Now to convert to acres, 1 acre is worth 40. Now this is something I don't know. I have to look this up as well. 43,560 feet squared, right? So remember our little conversion. If two things are equal, then I can just take and I can find, or let me say area in acres. Okay. So when I do this, I'm just going to take 146,750 feet squared, and I'm going to multiply it by a special one. I'm going to multiply it by 1 acre divided by 43,560 feet squared. Now, some students, have trouble. How did I know to put the feet squared on bottom and the acre on top? Well, this is technically over 1, right? So in order to cancel a feet squared on top, I need a feet squared on bottom. If they were both on top, then it would be feet squared times feet squared, which would be feet to the 4th. We don't want that. We want it to be left in terms of acres. So now we have acres left in the numerator. So now we're going to take this divided by 43,560. And I get, let's do 1 decimal place. I get area is approximately, I round this off to 3.4 acres. Oops. Okay. So that's how you can do a problem like this. It's a little bit more difficult because they asked us to convert it to acres, but I hope you can see this as a multi-step problem. You had to do a lot. I mean, we had to set up the Pythagorean theorem, but that was just the beginning. Once we got B, then we had to come over here and use our area formula, right? And then once we did that, we had to use the conversion of 1 acre worth 43,560 feet. And then that's our answer right there. Okay, so a difficult problem, definitely one of the harder ones you would run into in the homework. Okay, so now let's talk about similar triangles. Okay, so the nice thing about similar triangles, let me see how much we have left. Oh, just a little bit. The nice thing about similar triangles is they've been used for a very long time to do a lot. Even in old times, there's all kinds of things you could do with similar triangles. So two triangles are considered similar if they have the same shape, but not necessarily the same size, meaning that one is scaled up or scaled down version of the other. So again, they're the same angles, but think of it almost like what is it, architecture. You know how they build like little miniature models or they'll draw them on paper, and then there's some kind of scaling where they want everything to still be the same in proportion, but obviously one is smaller. The little miniature house is smaller than the real house they're going to build. So that's how similar triangles kind of behave, is they want everything the same scale, or I should say that in proportion with each other. Okay. So sometimes you can use a scaling factor. I don't actually oftentimes use that. I like to just kind of set up a proportion and then go cross multiply and go from there. So for two similar triangles, corresponding pairs of angles in each triangle are equal. So angle A equals A prime, and B equals B prime. I'm sorry, angle B equals B prime, angle C equals C prime. So what they're telling you is the angles are the same. Okay, so that's no big deal. The ratios of the side lengths in the two triangles are all equal. Okay, so that's a fancy way of doing it. What I like to do is, in general, I like to be able to, if I give somebody two triangles, and I give you two of the sides, you should be able to find, or three of the sides, you should be able to find the fourth. So what we can do is, let me see here. They want, for this one, they give us these two triangles and they are similar. So we're already saying these triangles are similar. Okay, so these have the same angles, but definitely different side lengths. So they want to find A and C prime. Okay, so they want to find this guy and this guy. Okay, so the first thing I'm going to do is I'm going to set up a proportion. Okay, so I'm going to compare this side to this side. So I'm going to set up A over A prime equals, and then that should be, let me see, where could I go from here? Oh, we know both of the B's, so that's going to kind of be the go-between. Okay, so I'm going to now use that this is equal to 9 over 6. Now notice I used big triangle to small triangle. Then I have to follow that same pattern when I do the other fraction, big triangle to small triangle. You have to follow the pattern with proportions. Whatever pattern you set up, you got to follow it in the other side of the equal sign. Okay, so now we have 9. That is not a, by the way, these are A's. And this is a 9. Okay, so this is actually what? Divided by 3 is 3, divided by 3 is 2. So we actually have A over A prime is equal to 3 over 2 if I clean it up, right? So now, but we also know A prime is 4. So I should have plugged that in from the beginning. Sorry about that. We know A prime is 4. So now we can cross multiply. Okay, and you do 2 times A would be 2A, and 4 times 3 is 12. And then once again, we divide both sides by 2. This is our old school math, right? Cross multiplying. We get 1 and 1, and this is 6 over 1. So we get A is equal to 6. Okay, so we found A is equal to 6. Now we have to find, which one did they want? C prime. So that means this time we're going to find C prime. So I'm going to do C prime over 12, right? I'm going to compare this. So now I'm going little triangle to big triangle, which is fine as long as when I compare it to B, I do 6 over 9 this time, right? Because now I got to go little triangle to big triangle. So whatever pattern I did, I have to do it on the other side as well. Okay, so now we're going to cross multiply again. This becomes 9C prime equals, what is that, 72. So then once again, we divide by 9, divide by 9. So we have C prime is equal to 8. And that's all you do. That's how you can work with similar triangles. It's pretty nice. Cross multiplication is one of the most powerful tools you will ever use in math. It's really nice and clean to work with. Let me see. I don't think I wanted to do this one. Yeah, that's okay. So yeah, that's about it for this video, you guys. If you have any questions, feel free to stop by our meeting times and let me know. All right. Thanks, you guys. Thanks for watching.